Good day everyone, I am Ma'am Andrea Jane T. Calo and our lesson for today is all about the difference between solid and fluids. Before we start our discussion, I have here a 3 bottle which are filled with water, sand and an empty one, which represents the solid, liquid and gas. Imagine we are flipping the bottle that is filled with sand, so the sand won't flow freely and the sand will stay at place making it more stable but heavier. Also, flipping the bottle with water, the water moves inside, sloshing around. This movement will affect how the bottle spins and lands as the water shifts. And for the last one, when flipping the empty bottle, since it's much lighter, the bottle will be easier to flip but less stable, which may cause the bottle not to land consistently. As we observed, solid like sand maintain their structure. These highlight how solid don't flow or shift their mass as easily like liquid and gas, in which liquid can move and flow, distributing the mass in the bottle as it flips. Also in gas, which is much less dense, causing the bottle to flip more unpredictably. Now, as we proceed to our discussion, let's be guided by our learning objective. At the end of the lesson, the student should be able to differentiate the fluids and solids by their molecular structure, demonstrate the difference in compressibility between solid and fluids by applying pressure, value the importance of the behavior of solid and fluids in real-life example. As we all know, everything around us is made up of matter. So when we say matter, it is anything that occupies space and has mass. Matter can exist in 2 fundamental states, which are the solid and fluids, in which fluids are classified into liquid and gas. Today, we're going to deepen your understanding on the difference between solid and fluids, in which solid and fluids differ in their characteristic because of their molecular structure. So when we say molecular structure, it is the arrangement of atoms in a molecule. Based on the illustration, the molecular structure of the solid, particles are closely packed in an orderly manner. Particles are banded together by a very strong force, which result in solids having fixed shape and volume. Imagine we put a rock inside a cup. The rock does not take the shape of the cup because its molecular structure are tightly bound and can't move freely. The movement of particles are restricted. It can vibrate but cannot move freely. Now, let's proceed to fluids. Imagine the cup is filled with water. As we observe, the water immediately takes the shape of the cup. Based on the illustration, the molecular structure of liquid, particles are clustered randomly. Particles are banded by moderate force which results in liquid having no fixed shape. As we observe in the illustration, the molecules in fluids are close to each other but can move freely, which allows the water to flow and adapt the shape of the cup. Now, let's proceed to gas. As we all know, gas cannot be seen with our naked eye. Based on the illustration, the molecular structure of a gas, particles are far apart in a random arrangement. Particles are banded by a very weak force which results in gases having no fixed shape and volume. For example, when we inflate a balloon, the gas particle inside move freely and spread out to fill the space. This happens because gas particles are far apart and can move independently, allowing them to occupy the available space inside the balloon. Now, let's proceed to the other factor that explains the difference between solid and fluids, which is the compressibility. When we say compressibility, it is a measure of the change in volume which results from a change in pressure. To apply compressibility, I have here a syringe filled with solid and fluids. Let's try to squeeze the syringe that is filled with sand. As we observe, the sand doesn't change the shape or compress easily. This is because solid like sand have particles that are closely packed together and resist being squeezed. Therefore, solid have a very low compressibility, meaning they don't easily change volume when pressure is applied. You can identify the importance of compressibility in solid in real-life situations, for example, constructing a building and bridges. Materials like steel, concrete, and bricks are used because they have a very low compressibility. This ensures that the structure remains strong and stable under heavy loads. Now, let's try to squeeze the syringe with water. As we observe, the water does not compress easily and the water inside remains almost the same. Therefore, liquids have a very low compressibility. The particles in a liquid are close together but can still move freely so they can flow. We can identify the importance of compressibility in liquid in a real-life situation. For example, in household plumbing, water is transported through pipes under pressure. When you turn on a faucet, the pressure built up in the pipes allows water to flow immediately and efficiently. If water were more compressible, turning on the faucet may result in delay or weaker flows, as the water would compress before moving through the pipes. Lastly, let's try to squeeze the empty syringe. As we observe, the syringe compresses easily. This happens because gases are highly compressible. The particles in gas are far apart and can be pushed closer together when pressure is applied. We can identify the importance of compressibility in gas in a real-life situation. For example, filling a tire. When we inflate a tire, we are compressing the air into a smaller volume, allowing a large amount of air to fit into the space of the tire. As air compressed, its pressure increases, which provides the necessary support and shape of a tire. Understanding the molecular structure of solid and fluids under compressibility help us understand how materials behave under pressure, which is essential for designing safe and efficient systems for real-life applications. Examples are in constructions, environmental, and scientific research. By understanding compressibility in solid and fluids, we can enhance safety and effectiveness across wide range, ultimately improving our daily life. Understanding the molecular structure of solid and fluids under compressibility help us understand how materials behave under pressure, which is essential for designing safe and efficient systems for real-life applications. That's all for today. Thank you.